you get this value. So this is less than the previous value, so you can continue. You can continue. Now, just substitute in energy equation, which is specific energy equation, y1 plus 25 over 2 times 9.81 times phi square y1 square. So y1, again, by try and error, you get this value. So this is less than the previous value. So Froude number, you calculate again using this equation, similar with the previous one. Then you get 9.8. So this is greater than the previous value. Then you can proceed. So determination of new sequent depths now. Step 5. New sequent depths you can determine y2 and new factor, new safety factor also. You can safety coefficient. You can calculate sigma prime. So y2 will be this value. This value. Then from y prime you get sigma prime, which is this is the safety coefficient. So less than 1.25, so it is okay because it ranges between 1.1 and up to 1.25. So you can proceed. So since this is in between, so you can proceed with this one. Then check the design for small value of Q. Just reduce discharge. Then you can check the design. What will happen? Okay. Step 6, determination of length of stealing basin or LB, or sometimes length of the jump. We say length of the jump, LB, and energy loss, E. So length of stealing basin, LJ, K, which is hydraulic jump coefficient, K, times Y2 minus Y1. So K, just for this case, 4.5 we take, 4.5, according to the Froude number. So energy loss at downstream of the spillway, which is the change in energy, E1 minus E2. So you get this equation finally. So you substitute this value, then this is the energy loss at downstream of the spillway. So amount of energy dissipated, just divide energy at the base, divide by total energy. You have total energy, initial total energy, which is this one, 62.555, including basin depths, 50 plus 5.055 plus 7.5. So if you divide, then amount of energy dissipated will be 49.4% of the energy of the flow will be dissipated. So further, I think once just it enters to the stealing basin, again it will jump like this. So just like this, it will jump. So you can calculate the horizontal distance of the jet trajectory. Jet trajectory, you can calculate using this equation, v naught square over g sine 2 phi. So this is phi is the leap angle of the trajectory motion. So jet trajectory height is given by this equation again. I think from mechanics you can drive these equations. So theoretical equation for free trajectory motion at any distance x, you can calculate using this equation. This equation above the floor of the spillway, you can calculate. So minus x tan phi, etc. You can use this expression. So x and y are horizontal and vertical coordinates measured from the beginning of the curve, which is in feet, and phi is angle between the horizontal and the floor at the beginning of the trajectory, at this point. Clear? At this point you can just use. So you can just have equation of trajectory motion. I think here you have the previous example. This is the curve. You can use this one. You see, this is just the trajectory. Just once you have bucket, then it will just eject to the air. So at any x distance, you can get equation of trajectory motion. So you will use this equation. So step 7, design of chute blocks, baffle blocks, and end seals you can design further. End seal means this one at the end of the stealing basin. You have chute block and also you have baffle blocks. So actually, according to the Froude number and the flow nature, you will select the type of stealing basin. It could be type 1, type 2, or type 3, or type 4 stealing basin in accordance with the Froude number result. So you can design the chute blocks baffle blocks, and end seals. Okay, so as a problem for this example, check the possibility of cavitation in the basin floor and estimate the scar downstream of the basin. So as a problem, please try this question. Okay, so as an exercise again, you can use this equation. So this is different from the example, which means you have width and also total discharge, total maximum discharge is given, then width of the spillway is given. But in the above example, width is already assumed, which means just wide channel, which is hydraulic radius equal to uniform flow depth, normal flow depth. But in this specific problem or exercise, width is given. So you will not assume. So you will use this 35 width of the spillway, then just use this Manning's equation, then Froude number again, you can use this equation. For any type of channel, Froude number you can derive using this equation. Froude square is equal to Q square T over GAQ. Using this, you can calculate, okay? Okay, so if you have any question, you are welcome. You can contact via Telegram or email or e-learning. So I think this is a good example. Please try this exercise. Okay, so you can just see how the flow is. This is the speed, overflow speed. So you just glide over the spillway surface. If you glide over the spillway surface, then finally, back to Thank you. Okay, so this is all about today's tutorial. Hopefully you liked the video. If you have any comment or doubt regarding this topic, please let me know and write down in the comment section below. I will definitely reply on it.